Today's webinar in particular is an important part of the series of webinars that discuss things like automation and tooling and data management, those particular things that are key to making open source scale, making management of open source scale. Now, before we get started, as always, we're going to have a look at the antitrust policy notice. And that is located on the Linux Foundation website for the full antitrust policy. If you are part of the Linux Foundation, if you're from a member company, please feel free to contact our counsel, Andy Updegrove, with any questions. Now, before we get bored with too many formalities, we're going to hand over to our actual speaker, Jasper. Jasper, of course, is someone who has a strong background in this area, and I know that he's going to explain some of that in a moment. The most important thing, I think, for those coming into this recording from places like, let's say, Japan, where I'm resident, or our Chinese audience, is to be aware that in the European space, we have an amazing automation work group. Of course, it's open to everyone around the world. We've had so much progress and discussion around automation and tooling. And recently, many of the key people involved in the automation work group have been encouraging webinars and contributing webinars to explain some of the progress and solutions out there. Jasper is one of those people, and over to you for the actual webinar itself.
Well, thank you very much for that kind introduction. Yes, I'm just going to go back to the title for a second. So this meeting is about the license management of free and open source software, especially in the context of OpenEmbedded and embedded Linux. To the agenda. So as a little bit of a disclaimer, for this talk, we expect a rough understanding on what OpenEmbedded is, as well as some core concepts. I mean, I will touch on them during the talk, but for your understanding, it would be better if you have some core understanding there. So what are we going to talk about today? First, I'm going to lose a few words about me and my company. Don't worry, it's not going to be too long. Then we're going to have a rough overview of how license compliance in OpenEmbedded should look like, or what the obligations actually are. We're going to have a look at the upstream tooling that comes with the OpenEmbedded project in regard to license compliance. And then as a result, why we thought that the meta-osselot project is necessary. I'm going to give a quick introduction to OSSelot. It's not going to be in depth. There was a talk last week, I believe, on the topic of OSSelot itself. So it's just going to skim over it a little bit. And then we're going to get to the topic of integrating OSSelot into OpenEmbedded. And then the end, if we have the time, there's going to be a quick demo and a Q&A. That's about it. All right. So who am I? Hi, my name is Jasper. I work at Iris since 2019 as a DevOps engineer, and I mainly work on infrastructure topics as well as our embedded Linux build for our main product, as well as doing development workflows. And I'm somewhat of a tooling guy, so mainly I just glue code together. I'm not much of a developer per se, but I manage. Automating stuff makes me happy, and the obligatory disclaimer for this presentation, I am not a lawyer, so I'm not going to give you any legal advice here, so take everything with a grain of salt. but I'm going to give a rough overview of what I believe are the obligations as well within this talk. But just as the disclaimer, I am not a lawyer. Okay, so Iris GmbH. So Iris GmbH is my current employer, and it sits in, or it's based in Berlin, Germany. We have just over, I think, 150 employees. I'm not quite sure how up to date that is. I think we might be bigger by now. And we do passenger counting in public transport by using infrared cameras, and we achieve over 99% accuracy doing so. You might actually have seen it at some point in public transport. They are like placed right above the door. And this data is then used for scheduling, optimizing schedules of trains and the actual train size, so the number of carts, and also the distribution of ticket sales within the network of public transport providers. And we have quite a lot of vehicles actually using our hardware, basically worldwide, and we heavily rely and also contribute to a certain degree to open source software. And just if you're interested in us, visit us at our website. That's about it. Okay, so license compliance and OpenEmbedded. I try to simplify a little bit the obligations. So what we're really interested in is everything that is shipped to the customer, because those are the parts that really need to be checked and need to be to conform to the licenses they come with. So roughly speaking, you need to provide the original source code for copyleft licensed software, and you need to provide the modifications in those cases as well, if any. You also need to make sure that you specify which part is modified, and then you also need to provide the copyright notices and the licenses from the license text, and as well as from the source code. And the same goes basically for the licenses. So any licenses within the license file itself, as well as any licenses mentioned in the source code. And also something that many people forget is that you additionally would want to provide the tools and scripts that you use to build the software. That's a part of the GPL license clause. So having a good way of like splitting your company's IP from the open source tools is always a good thing to have. So I'm just going to show you some upstream workflows. So how license compliance is achieved in OpenEmbedded. So the first option, which I quote unquote the old workflow, is using the archiver BB class that is directly from OpenEmbedded, and that can help you to create source code archives for open source or copyleft source code. There's a word missing there. And you then also can use the license folder from the OpenEmbedded deploy directory for collecting the top level licenses as proclaimed by the recipes themselves. That has some downsides though, because these licenses that OpenEmbedded declares usually only contain the top level license of the project. So it doesn't go into depth and check for any licenses that are defined throughout the project source code. And as far as I'm aware, the copyright statements aren't used at all. Although take that with a bit of grain of salt, because I'm not 100% sure on that. And also, issue we actually ran into is that statically linked build time dependencies are not included because the build system or the archiver system doesn't really know about them. They are only relevant during the build and not during the runtime. So the archiver doesn't care about that. It only cares about stuff that is added at the runtime although statically linked dependencies might actually basically infect the runtime sources with stuff that's linked from there. Yeah, and then another problem you have is that it's just the sheer amount of source code or archives that you're left with. So you end up having like gigabytes of source code archive, and in the end, you don't really have a workable SBOM, something that, for example, some of our customers are asking for, but it's also getting more and more predominant in the industry. So yeah, that's not a great option really. The second option, which I call the new workflow, is the create SPDX BB class from the OpenEmbedded project, and it's actually quite a complex and powerful tool. It can also, well, first and foremost, it creates SBOMs. So for those that are unaware, SBOM stands for Software Bill of Material, and basically it's a structured file that contains information on build dependencies, on CVEs, basically everything that you would want to know from a build perspective, what actually went into your software. And yeah, this BB class is quite powerful. You can actually create the source code archives from there as well, and it fixes a lot of the issues that the old workflow had. But it's quite complex, so I'm not going to go into detail here. There are great videos on that as well. So if you just go to Joshua Watt's YouTube channel, it's basically the guy who worked on the SPDX class. He has a great video on the topic. However, the Create SPDX class has still some issues, and most notably for us was that the license information in there is simply said quite bad. The license detection is quite oversimplified, so it only checks for SPDX headers using a regex, and while that is something where we want to be somewhere in the future, that everything is declared using SPDX headers. As a matter of fact, it isn't as of now. So a lot of the licenses actually, well, fall onto the rug, and you can't really fix that easily in code. Because there's just historically there have been many ways licenses have been declared in source code. So there's no simple solution for that. And there are dedicated license scanner tools out there, and they do a lot of complex scanning, and even they are too unreliable really to rely on the data unchecked. Yeah, that's a really bad situation for us. Because on the one hand, we have customers, and especially as if you are component suppliers, that holds true. And we've heard from other companies that they have similar issues. There really is an increase in demand for these kind of information from various contractors, and yeah, it's becoming a standard throughout the industry. And the problem we are facing is that on the one hand, we want this detailed information, and on the other hand, manually generating this information for a whole Linux system is quite cumbersome and a lot of work. But basically, we have to do it because the automatically generated SBOMs from various tools just don't cut it if you are really serious about license compliance. Yeah, as I said, unfortunately, it's a huge burden, especially if you are in a small or medium-sized company. So yeah, if only there was a way to actually distribute this burden throughout the industry. And that's really where the OSSelot project comes into play. So what is the OSSelot project? So it's a relatively new project. It started roughly a year ago, and it is a open source database of curated data. So you have trained curators that manually create and validate high quality SPDX files or SPDX SBOMs for the various open source software. And these curation data is then made available under the license of the CC0 1.0 universal. So it's basically public domain. And the SBOMs are then made available in GitHub and via REST API. And the basic idea is to crowdsource the necessary creation data, so the information that basically all companies that are serious about license compliance need, and basically, yes, provide a mechanism to distribute this effort throughout the industry. All right, so we have the OSSelot project, and we now want to actually use this data in our embedded Linux distribution. So the first question someone might ask is, why do we actually include it right in the build system? Why don't we just take the build artifacts and work from there? Well, mainly we want to tackle the problem at the root. So having it right in the compile or during compile time there is always a great thing. And the build system actually includes a lot of useful information that we meta information that we can leverage. We're using some of it right now, but we are also hoping to improve on that down the line. Also, the by using the OpenEmbedded mechanisms, we actually can reuse a lot of the existing mechanisms. So like the state cache, which basically means you don't have to rerun every task every time you run the build, basically, and you have a sense of task dependencies, etc. So it's a really powerful framework for that. And also, it's a well-known process in the embedded community. So everyone using OpenEmbedded and having a somewhat thorough understanding on how it works will take a look at the integration that we wrote and will be like, oh yeah, okay, I understand what's going on. All right, so meta-osselot. So the meta-osselot layer is the layer that we wrote for that. So if you're not too familiar with the OpenEmbedded system, so basically a layer is a collection of recipes. So basically it instructs OpenEmbedded on how certain tools are built or fetched. And also you have BB classes, which basically are shared code that you can use throughout recipes. And this layer basically wraps it all together in a easily shareable collection of code. Yeah, so this layer that we wrote is available at GitHub, so github.com, rs GmbH, and meta-osselot. And yeah, mainly it consists of 3 components. So the first component is a recipe that instructs OpenEmbedded from where to fetch the curation data from OSSelot. And then we have a BB class, which will then provide the logic on how to match the OpenEmbedded packages that we are building against their OSSelot counterparts. And then also we have various BB append files. So if you're unfamiliar with that, basically we use that to add some additional information to existing recipes from upstream layers. So from, for example, the OpenEmbedded core layer, just for more convenience when using OSSelot. Yeah. All right, so we're going to first take a closer look at the OSSelot package analysis native BB recipe. And basically what it does is that it takes the a Git source repository. By default, that's the OSSelot repository with the latest available data. And it clones that repository into a work directory, and it basically searches for all available packages and versions within this source repository. And it then writes that into a JSON file, which we can then later use to validate whether OpenEmbedded package is actually available in OSSelot. So there was a first important design choice there. We opted to go with the Git repository rather than using the REST API that OSSelot provides. That is for multiple reasons. The first reason is that with the REST API, we would only be able to really use the packages that OSSelot provides, at least out of the box. By using the Git data, it's really easy for someone who actually wants to clear their own data to just fork the existing OSSelot repository and then add the data on top. So it makes it really easy to get a workflow going if you actually want to start curating your own data. Additionally, there's quite a lot of logic in the OpenEmbedded Git fetcher. So, for example, it would only rerun and refetch data, rerun the Git repository if it's actually necessary due to changes in the repository, and otherwise it will just reuse the data available. And also the raw data just gives us more flexibility. We can actually give package name suggestions if the package that is looked for isn't found. And we can also reuse other versions if we encounter a version mismatch. All right, then we'll have another look at the OSSelot BB class. So as we just saw, the recipe was actually well, the point of the recipe was basically to get the data available, and the BB class will now match the OpenEmbedded packages against the OSSelot database. So what it does is it reads the JSON file that was created in the previous step, and it then attempts to find the OpenEmbedded packages in basically the list of OSSelot packages. And if it fails, it will suggest close package matches and exit. And if it actually finds the package, it will then attempt to find the best matching version. If it doesn't find the perfect match, it will then reuse another version, basically, so that you only have to curate the difference or the mismatch between the versions. It then calculates the checksum of the source files within the package, and then extracts the corresponding data from the OSSelot SPDX file, and will write this information into a meta file in the OpenEmbedded deploy directory, so that you can then easily check is the source code identical to the source code that has been validated by the OSSelot project. All right, so well, we ran into a few issues. So the biggest issue was, well, actually that one was quite easy to fix. So some packages are available in OpenEmbedded in a different name scheme than in OSSelot. So, for example, we have expat, and in OpenEmbedded, the recipe is called expat, and the version number is just written as 2.5.0. And in OSSelot, it's libexpat, and well, the version string that you can see there, so r_2_ and so on. So we need to provide a mechanism that we can actually match these kind of package name mismatches, basically. Then another issue we run into is that occasionally OpenEmbedded will use package release tarbals rather than the original Git code. And OSSelot instead will use the Git code. So basically it will use archive tarbals from GitHub or the various Git original repositories. And this will result in slight differences in source code sometimes. So occasionally some packages will then already have, for example, CMake scripts or configure scripts run. So that will lead then to files not being curated by the OSSelot project. And another aspect is that OpenEmbedded actually patches some source code. So there's a mechanism called do patch. So you can modify original source code to the needs of the OpenEmbedded project. And that will obviously lead to checksum mismatches with the code that has been curated in OSSelot. All right, there's a question in the chat. Do you mean packages or recipes? That's a good question. So the recipe name really. So in in Yocto or OpenEmbedded, the expat recipe is called expat, and in OSSelot it's called libexpat. Yeah. All right, so another issue we run into is that OpenEmbedded will ship some software that doesn't include a point release. Basically, config files that are source code that is stored within the layer repository itself. So you see that quite a lot with some config files for existing open source software. So if OpenEmbedded wants to ship a default config, for example, and they actually might contain code that is relevant for license compliance. But since we don't have a point release, it's quite hard to get this information into OSSelot. So that's something we also have to figure out at some point. Yeah. So a lot of these issues can actually be fixed using the BB append files. So in meta-osselot, we heavily rely on OpenEmbedded mechanism called BB files dynamic. So basically what it does is that it will dynamically load BB appends depending on which layers are actually used within the build. So if you use Meta OpenEmbedded, for example, and there's a recipe in there from which we know that it doesn't, the OSSelot name doesn't match the OpenEmbedded name, we can then add a BB append file for this specific layer that will then basically redefine the OSSelot name within this recipe. Same goes with the version. We can also use that for ignoring packages that are not relevant for license compliance. So as I mentioned earlier, some recipes actually use the release tarballs, and those on source code mismatch, those are usually, as I said, due to pre-run configure scripts. They are not relevant from a license compliance perspective because they are basically a generative step that is run before the build. So the relevant source code is already in the repository. It's just that there's additional data that has been pre-generated. So in these cases, we can actually ignore them, and we can do that directly in the BB append in the meta-osselot layer. So it's not something that everyone has to do in their own layers. We can do that basically at one central point. Also, we can ignore packages that aren't relevant. So basically, we at this point we ignore everything that has a native suffix because we deem it not relevant for license compliance. As I said, we are only interested in packages that are actually shipped to the target, so to the customer. So yeah, basically ignoring all native packages drastically reduces the number of packages that we have to check. And yeah, also we can use the BB append files to manually set packages to be ignored. For example, in the actually image recipes. So for core image minimal, we set it to be ignored because it's just basically a meta package that doesn't install anything itself, but it just defines which other packages to use. Yeah, right. And we also have a checksum equivalence mechanism. So if we have a patched file and we deem the patch actually not to be relevant from a license perspective, we can define equivalence. So we could then say, okay, even though the file has a different checksum than this one that has been already curated, we basically take the checksum of the curated file and set it into relation to the checksum of the patched file, and by doing so say, okay, this is fine from a license perspective. Yeah, so using these BB append files, we can fix many, but unfortunately not all issues that I just mentioned. So there are some issues still open where we have to figure out as we go how we want to deal with that. All right, so here we have an example BB append file. This is for basically debug recipes of any version. And this is basically the case I just mentioned. So we already have basically a pre-run configure script here. You can see the output of this configure script, and this isn't relevant for us from a license compliance perspective. So we can now say on a global scope within meta-osselot, okay, please ignore these files. We don't care about them. And also we have a hash equivalence defined here. So we so there was obviously something patched in this configure AC script, and so we verified if the patch has any relevance from a license compliance perspective, and it doesn't. So we can just define a equivalence and don't worry about that, basically. Yeah. All right. So how do you actually enable meta-osselot in your build? It's quite simple, actually. You just need to clone and add the meta-osselot layer to your build. Make sure that you use the appropriate release branch. So that's, for example, Kirkstone is the current LTS that the OpenEmbedded/Yocto project provides. We basically want to support LTS releases mostly, but it will also work with other branches. Then you inherit the Ocelot task in your local conf file or your dist-conf file, and that will basically cause every bitbake command to run all relevant Ocelot tasks. So, for example, if you run bitbake core image minimal, it will build the image, but it will also do these Ocelot tasks. Alternatively, if you're only interested in the output of Ocelot, you can also use the run only flag, which will then skip all the other build steps, and it will only run the tasks that are necessary to actually come to the Ocelot output. All right. So speaking of Ocelot output, so what actually is the output of Ocelot? So currently we have a currently meta-osselot will create a folder for all relevant packages. This currently also includes native packages, although you will see a status message that it has been ignored. So, but yeah, basically it will create a package, a folder for all packages, and within this packages it will write the meta file. In this file, it will state the Ocelot status for this package. So whether it's been ignored, for example, because it was a native recipe, or because ignore flag was set within the recipe, it will tell you about version mismatches. So basically, the package you were looking for was found in the OSSelot database, but not in the exact version that you were hoping for. Or maybe it wasn't found at all, or you had a perfect match in the versioning at least. That doesn't mean that necessarily mean that all the source code is identical due to the patching mechanisms of OpenEmbedded. Then it will also list which source files have been ignored. It will list the checksum mismatches that might have occurred, and same with the equivalence of checksums, and in the end, basically everything else that has matched. So if actually a package was found, whether in the matching version or with a version mismatch, we will actually also provide all the OSSelot data on this package, so it will also be saved in this deploy directory. All right, so what are the next steps? So as it stands, we don't have that many packages covered yet. I think maybe around 5% of all packages in the core image minimal image are currently covered in OSSelot. So we really hope to up the numbers here. Ideally, we want to achieve 100% coverage for the reference image, at least for the LTS releases, after starting with Corkstone, basically. Then we still need to figure out how we want to deal with these OpenEmbedded specific packages that I mentioned earlier. So basically packages that don't have a point release, or just add source code from the layer repository. We want to evaluate reusing data from the create SPDX class, because it actually contains a lot of useful information, we believe. So, for example, which source code files were actually relevant for building a certain package. It's not as easy. We already started evaluating this. There are some things that we believe might be a blocker, although I just saw yesterday actually that Joshua Watt released a new video on the new SPDX3 format that is now available in Yocto. So maybe things will change there, and hopefully we can actually reuse the information of the create SPDX class, because it's quite powerful. And then also we want to work closer with the OpenEmbedded maintainers. Ideally, we would want to get the OSSelot integration upstreamed, so it's an official part of the OpenEmbedded distribution. Although, there's still a lot to be done, I think, before we can reach that point. Then basically anything that is in the issue tracker. So we use the GitHub issue tracker. And also, if you find any issues, please ping us there. So how can you help? First of all, get involved. So contributing curation data to OSSelot is it's a tedious step, but it's also a necessary step. So if you want to help there, then hit them up. They will give you an introduction on how to do that, actually. And on the other hand, on the side of automation, you're welcome to help us improve meta-osselot. And then other than that, basically spreading the word and talking to us, and giving us your feedback. All right. Any questions?
My goodness. First of all, I just want to say, Jasper, thank you. I was impressed with this webinar because it was dense with information in a way that's easy to understand. You gave us huge value for money. And we paid nothing, but it's still good value for money. We have a question. It's from Anton, and it was referring to the earlier part of the presentation, and he was asking, do you mean packages or recipes? Anton, could you clarify that just to give us context here in the Q&A?
Yeah, I think I already answered
you already
question,
covered
but
that.
unless he actually meant something else. So
actually, can you hear me?
Yes, I can hear you.
Yes, first of all, thank you very much for this presentation. And yes, I clarified because it's confusing a little bit, because recipe could have more than one packages inside.
Yeah.
And it's always confusing in Yocto because
I know.
What exactly you mean?
Yeah. That's also something we've been struggling a little bit when evaluating the SPDX class. As it stands right now, unfortunately, we can't really differentiate between package and recipe. So basically, we assume that every piece of source code within the repository you clone, or the source code you use for the build, that's license compliance relevant. As I said, you can use the configuration flags basically to ignore those, but for the time being, unfortunately, we by default deem everything relevant from a license compliant perspective.
Okay, so basically you answer my question, but maybe I just try to put the second one. So
sure.
So what is actually outcome of it? You just found everything what in OSSelot database and looks like what you have in your build, right? Because
Sorry, I didn't get that
if we're still
question.
talking
So
about,
yeah.
I mean, so as a result, you applying of your layer allows to find all, I would say, recipes which are already in OSSelot database and we use
Yeah, exactly.
source bill of materials.
Yeah.
Okay, so I hope basically that it will be something about bill of materials, because what we are working on now, it's merging metadata from unstriped binaries with source code, with
Okay.
source
Yeah.
files.
Yeah.
So do you do something in this direction?
No, not yet. So with the evaluation of the create SPDX class, we hope to do something like that. So for those that don't know, the create SPDX class will actually provide information on which source code files went into which binary. Unfortunately, during our first evaluation, it looked like basically it's from a technical point, this information. It isn't really from a license compliance point. So for example, we had a header file that basically just had a define, but it still has a license compliance statement basically, and it's used by the compiler, but the compiler will not include it in this information because it doesn't provide any real quote unquote source code. So I'm not 100% sure yet on how we can reuse that. But yeah, as I said, that's something we still want to evaluate in detail. Yeah.
Okay, thank you. I hope I can share my outcome to OSSelot as well.
Yeah,
It's actually what we
sounds
want
good.
to do, because we scan everything in any case, so it makes sense
Okay,
to contribute. Yeah. Okay,
yeah.
thank you very much again.
Yeah, thank you. Okay, then Steve had a question. If curation data is collected via a Git repository rather than pulling via REST API, does that mean you're working with a snapshot of curation data? If so, is there a means of refreshing the curation data, which, like security vulnerability info, might be updated even though the package being built is still the same? Yes. So by default, as I said, we are using the Git repository by the OSSelot project. And we are basically telling BitBake, which is the tool behind the OpenEmbedded OpenEmbedded platform, basically, or built environment, to always use the latest data. So by default, you can change that. So if you want to use a snapshot, you totally can. That's configurable, but by default, it will always use the latest data. So what it will do is actually, when you run the bitbake command, it will check on the remote Git server, have there been pushes to the main branch, which is the default in the OSSelot project. And if so, it will then actually pull the new data. And if not, it will just reuse the data that's already existing, which is quite nice. So basically, it only needs to run when there have been changes. Yeah, but yeah, by default, it will take the newest data. All right. So if there are no more questions, I will just do a quick demo. So I have a embedded Linux setup here. So I'm using CAS in this setup. Oops, on my Linux machine, that wasn't a good idea. And basically, what I'm going to do now is I already preloaded it with patched data. So I'm just going to do the run only do populate OSSelot. And what that should do, it should take the patch data and try to match it against the OSSelot database. And we can actually already see output here. So if you go through that, it will actually give us a warning if a package wasn't found in the database, and will also give us close-ish matches in the database. the ones that are here look, well, not as promising, but the reason for that is that we already basically cleaned up everything that was available in OSSelot. So yeah, don't worry too much about those. And then we also can see that in some cases, the specific version that we were looking for is not available, but a different version is available. So we will then reuse that.
Jasper,
so then
we
it
are
will
just seeing the slide still. We're not seeing.
I'm so sorry. Yeah, give me a second. I need to reshare my screen. Now you should be able to see something.
Yes, much better. Thank you.
Yeah, thank you. All right, so just to reiterate, so I have a build prepared here, and I just run a command to do the OSSelot checking, basically. So it's also in the documentation on the README of the project. So I only run the do populate OSSelot command because I don't want to compile everything right now. And as we can see, we then have output whether a package was found or not in the database. And it will also suggest close matches if it's not found. And yeah, as I said, like these matches, they seem a little bit wild now, but that's basically because we already included all relevant matches. So we basically fixed that already via BB append files. And then also we have cases where a specific version that we are looking for is not available in OSSelot, and then it will fall back in to using a different version that is available. And then basically we would only have to look at the diff, hopefully. All right, so it's, yeah, the Linux kernel, I think we can skip that. That will take a while. And if we check in the deploy directory now, we have a OSSelot folder with all the packages or recipes. And if I run a tree command now, we can see that we have some meta files depending on the package. So for example, in SOCAT, we only have a meta file, so that already indicates that the package was not found exactly. So it will write the status report in the meta file. And then we have some cases, now I can't remember which it was. Let me check again. So for example, the free type. So if we check in free type, we have a version mismatch. And we can actually see, okay, there's some checksum data missing here. So these files aren't available in the OSSelot database. And I guess this is also with the docs. This is probably due to the usage of release tarballs in the OSSelot build, in the OpenEmbedded build. And then we can see here some checksum data mismatch because there have been changes to this documentation or to actually to source code as well throughout these versions. And then in the end, there's quite a lot of difference in this package, but we can see there's at least some data that we can reuse here. And it just basically gives you a rough overview on how much you would actually have to recurate for this package. Let's see if we can find a package that actually has a version match. We can actually see that from the naming as well. So for example, here in OSSelot, in OpenSSL, we are looking for a 3.012, but the information that is made available to us is only a 111W. So we already know, okay, this is a version mismatch. So just, yeah, checking with tree in this case, it just helps quite a lot. So let's see actually where we have something that does match. Or we can also just do a grep for found, basically. That will give us a list. And as you can see, that it's currently the direct matches are limited right now. So that's something we hope to improve on. Yeah, and then we can see, okay, we have some ignored files, which I stated aren't relevant in this case. We have some checksum equivalence data matches. So there was something patched in OpenEmbedded, and we deemed that to be not relevant from a license compliance perspective, and everything else matches. So basically, this package is done, and we could just ship the read line SPDX data that is made available here. So then you have your SPDX JSON, your OSS disclosure, and whatever you want, basically. All right. Any other questions? Doesn't seem so. I think we're good on time as well.
We are.
8 minutes left.
Yeah. So Jasper, this is a very interesting field. And one thing I wanted to ask was if people want to get involved with helping the development around this, you know, let's say someone wants to get involved, they're from Japan or Korea or China. They might have some challenges with reading a lot of English and so on, or joining calls. What would be the easiest way to get started if they wanted to work with you on this? Not just use it, but help develop it.
Yeah. Well, not speaking English would be a bit of a problem. That's always a challenge, obviously, a language barrier. But yeah, I guess, well, as I said, the issue tracker on GitHub. So if I'm just gonna, I think I should have it. Should have a link to the repository. Yep. So just yeah, head to this repository and open your issues in the issue tracker, or you can also do feature requests, or yeah, basically anything, any suggestions you have. You also have my email address here somewhere in the beginning. Oh no, it's gone. So I'm just gonna oh, how are we gonna do this? Okay, I'm just gonna write my email address out real quick in the video as well, so that anyone can contact me if they want.
That's fantastic.
Apparently that got dropped at some point, so let me just reshare my other screen. So this is my email address if you want to contact me. That was improvised to the maximum, but it works.
No, that's how we do things here. I love the way that you typed your email address in a terminal. That's giving you full points on the open source hacker score. This is great, and you know, I'm going to be sharing this recording with people, and I think it's something where hopefully, especially in places like our China supply chain, we have a lot of people looking at what's happening around the world and looking at Europe. So I hope that people will be able to learn about this. And you know, audience, everyone, great questions. Thank you very much. And a final note before we end, I just noticed that Jasper's a Vim user. So I used to live very close to Bram Meulenaar, the primary author of Vim in Switzerland. And as you might know, Vim's author, Bram, died last year, quite young and so on. Great person, huge figure in the open source community. And for those of us from Europe, I'm from Ireland. I know I sound American, but it's partly a head cold and partly just being too international. You know, people like Bram, I think, helped build our early community in Europe. And people like Jasper have picked up that torch and are right here today. Thank you so much. It's just fantastic. And thank you, audience. I'll put this recording online quite soon. Have a beautiful day. Be safe, be healthy, be well.
Thank you. You too. And thanks for having me again.
Great pleasure.
Bye-bye.
Farewell. Bye-bye.